A z-score specifies the precise location of each value within a distribution. The sign tells you whether it's above the mean on the right or below the mean on the left. And the numerical value specifies the distance from the mean by counting the number of standard deviations between x and that mean. And for our purposes right now, we're speaking of only populations. This could also be done with samples, but just for the sake of simplification, we're just covering populations really in chapter 5. Or I should say that I am. I think this could be expanded to samples, but it's enough for us to get the picture about this for our future purposes in other chapters. So here's a depiction. If you look at the mean is 0 standard deviations from the mean. I know that sounds silly, and thus it's given a z-score of 0. A score that's 1 standard deviation above the mean is given a z-score of 1. A z-score that's 2 standard deviations above the mean, 2. And of course, the negative z-scores. Now, I should say that we're oversimplifying here. For starters, there are scores below -2 and above +2, but they're just not represented here. The highest your table goes, I believe, is +3.5 towards the back of the book. And there are fractions. So is there a z-score of 1.1 and -0.7? Well, of course. You'll also notice, I hope, that the sum of all the z-scores is 0. If I add up all the possible z-scores, 1.1, -2.1, 4, -4, -1, +1, they're all going to add up to 0. So they balance each other out. The z-scores sort of cancel each other, but they tell a story. If I have a score that's 2 standard deviations above the mean, it's fairly far from the mean, and as we'll speak of in chapter 6, you'll know exactly how far that is from the mean and what percentile rank a z-score of 2 would have. Conversely, if it's 1 standard deviation below the mean, that's not as extreme, and of course it's going in the other direction. Here are formulas. If I have a value of x, a raw score, can I convert that to z? Well, sure. It's just the raw value minus the mean divided by the standard deviation, and I can convert that to z. Can I go the reverse direction? If I'm given z for a value, can I convert it to the raw score? Sure, absolutely. And it's fairly easy to do. You'll see that that x formula is just an algebraic conversion if you're into algebra. You don't have to be. We give you all the formulas. So here's an example of a situation, and who knows what this means. Maybe this is a age of first cataract, an average of 65 with a standard deviation of 3. So 1 standard deviation below the mean would be 62. 2 standard deviations below the mean would be 59. So 59 might be fairly young to develop cataracts, which are a disorder of the eye. And I can convert to get a z-score, let's say. For instance, let's just sort of do this informally in our heads. What if we had an age of 59? Could I convert that to z? Sure. That'd be 2 standard deviations below the mean, when I can clearly see that the standard deviation is 3. I got 1 standard deviation below, which would be 62, and a second one would be 59, and so that'd be a z-score of -2. So the patient there would say, well, geez, that's an abnormally young age to develop cataracts, which it might be. I don't know. Let's take another example in which we're actually doing conversions. And here's the math. Let's say we had a 56-year-old, which is not much older than me, actually, and they had a cataract. Could I convert that to a z-score? Yes. And I've pointed the arrow as how far away 56 fell. That would be 56 minus the mean of 65 divided by 3. That person would be 3 standard deviations below the mean in terms of age. Very unusually young to develop cataracts. And that would be, well into the first percentile, so quite young. Could I go the reverse direction? Let's go over here on the right. Let's say I just told you I had somebody in the office today, if I were an ophthalmologist, that person was 3 standard deviations above the mean in terms of age of developing cataracts. Well, can I convert that and get a raw score? Sure. 65 we know the the standard deviation is 3. Plug in the number of standard deviations with also 3. So it's a z-score of 3 above the mean, and the standard deviation is 3. So 65 plus 3 times 3, and just take for granted that I'm telling you that someone came in the office today that was 3 standard deviations above the mean, and that's just 65 plus 9, and I can convert and know that person was 74 years old. Now, these are just made-up examples. I don't know that this is the age that people develop cataracts, but I just want to sort of run this by you that this is a perfectly plausible or relatable example that we can look at and decipher where people fall on that curve.